Let's look at some applications of linear equations. We're going to run through several different examples of problems that can be solved by setting up and solving a linear equation. My first type of problem is just an unknown number problem. So basically this problem is describing an equation in words. And so we have to translate the words into an algebraic equation. The problem says, twice the sum of a number and 4 is equal to 3 times the number. Find the number. So twice the sum of a number and 4, well, the sum of a number and 4, sum means add, so that would be x plus 4, and twice means we're going to take that sum and multiply it by 2. So I'll write that as 2 parenthesis x plus 4. Then the problem says is equal to, that's my equal sign, 3 times the number. 3 times the number would be 3x. And so there's my equation. Twice the sum of a number and 4 is 3 times the number. And now we can solve this using the strategies we've learned in the past. We can simplify by distributing the 2. So 2x plus 8 equals 3x. And then we can isolate the variable. So if I want to put the x's on the right-hand side this time, I can subtract 2x from both sides, and I'm left with 8 equals 1x. And that's my answer. X equals 8. Example 2. The area of the Sahara Desert is 7 times the area of the Gobi Desert. If the sum of their areas is 4 million square miles, find the area of each. So in this problem, we technically have two unknowns. We don't know the area of the Sahara or the area of the Gobi. All we're told is that the Sahara is 7 times the Gobi. So if we call the area of the Gobi Desert x, then the Sahara would be 7 times that, or 7x. So those are my unknowns. The next sentence says the sum of their areas. Sum means addition. So that means if I take the 7x plus x, that has to equal 4 million. And there's an equation that I can solve. 7x plus 1x is 8x. So 8x equals 4 million. Divide by both sides by 8. X equals 500,000. Now let's see, in this problem, we're technically not done because the problem says find the area of each. And if you look over to the left, we said that the area of the Gobi Desert is x, so that's the 500,000. So Gobi Desert is 500,000 square miles. But then to get the area of the Sahara is 7 times x. So I'm going to take 7 times 500,000. That's 3,500,000. And that is the area of my Sahara Desert. In this problem, we can take a minute and make sure that these answers make sense. They seem reasonable to me. They're large areas. These deserts are pretty large. If I had gotten something like a negative number or maybe a tiny decimal, I would be really concerned that maybe I made a mistake here. I also noticed that the Sahara is 7 times bigger than the Gobi. And if I add these two numbers together, I do get that 4 million square miles. Example 3. A 46-foot piece of rope is cut into 3 pieces, such that the second piece is 3 times as long as the first piece, and the third piece is 2 feet more than 7 times the length of the first piece. Find the length of each piece. All right, there's a lot going on in this problem, so I'm going to start by drawing a picture and then just kind of going one word at a time and trying to label things. So we have a piece of rope, and the total length of that piece of rope is 46 feet, and we're making 2 cuts so that we have a total of 3 pieces. I'm told that the second piece is 3 times as long as the first piece. So that means if I call the first piece x, the second piece would be 3x, 3 times the first. Okay, then it says the third piece is 2 feet more than, so plus 2, 2 feet more than 7 times the length of the first piece. So if I take 7 times x plus 2, that would be the length of my third piece. Now that I have my picture labeled, the next step is to get an equation. And I know that the total length of the rope is 46 feet. So if I take these 3 pieces and add them together, x plus 3x plus 7x plus 2, it has to equal 46. And there's my equation. To solve this equation, I'm going to combine like terms. 1x plus 3x plus 7x is 11x, plus 2 equals 46. We can minus 2 from both sides, so 11x equals 44. Divide both sides by 11, so x equals 4. Now we're not done. We want to find the length of each piece. And so if you think back to our picture, the first piece was x, so my first piece is 4 feet. And that answer seems reasonable to me. Again, if I had gotten a negative answer, I would be concerned. Does it make sense to have a negative length of rope? But 4 feet makes sense. So first piece is 4 feet. The second piece is 3 times x. So if I take 3 times 4, that gives me 12. So this middle piece is 12 feet. And then to get the third piece, it's 7x plus 2. But x is 4. So 7 times 4 plus 2, that's 28 plus 2, or 30 feet. So notice to get the lengths of the other pieces, I took my x equal 4, and I plugged that into the expressions I had in my picture. So the 3 pieces of rope are 4 feet, 12 feet, and 30 feet. And you can double check if you add these numbers up. They do total 46 feet. Here's another example. The length of a rectangular sign is 2 feet less than 3 times the width. Find the dimensions if its perimeter is 28 feet. So I'm going to draw a picture. We have a rectangle, and I know that the length is 2 feet less than. So less than means minus 2. 2 feet less than 3 times the width. So I'm going to make the width x, and then it's minus 2, 2 feet less than 3 times x. So the length can be described as 3x minus 2. 3 times x minus 2. 3 times the length, or I guess it's the width. 3 times the width minus 2. All right, so we have our picture labeled, and then the other information that we're given is the perimeter is 28 feet. Perimeter means distance around the object, and when you have a rectangle, to get your perimeter, you always can take your length times 2, because there's 2 sides with that same length, plus your width times 2, because 2 sides of the width. So using that fact, using that information, if the perimeter of this rectangle is 28 feet, we can take 2 times 3x minus 2, that's the length, plus 2 times x, that's the width, and that has to equal 28. To solve, I'm going to distribute the 2, so 6x minus 4 plus 2x is 28. Combine like terms. 6x and 2x is 8x. So 8x minus 4 is 28. Add 4 to both sides. 8x equals 32. Divide both sides by 8. So x equals 4. Now if we want to find the dimensions, that means we have to give both the length and the width of the object. And x was the width. So width is 4 feet. The length is 3 times x minus 2. So 3 times 4 minus 2, 12 minus 2 is 10. So our rectangle is 4 feet by 10 feet. And that is something that has a perimeter. If you add up the lengths of all the sides, you do get 28 feet for your perimeter. Here's another example. This problem's a little bit different than the previous problems, but let's read through it first and then talk about how we can solve it. Nancy drove 2.5 hours in rush hour traffic. When traffic eased up, she was able to increase her speed by 40 miles per hour and drove another 4.5 hours. If the entire trip was 362 miles, how fast did Nancy drive in rush hour traffic? So in order to solve this problem has information about times, speed, we know a distance. So to solve this problem, I'm going to use the fact that the distance you travel, d, always equals your rate, or your speed, times time. So if you take the speed that you're traveling at and multiply it by the time, it'll give you the distance you've traveled. So we're going to take advantage of this fact to solve this problem. I'm also going to create a table to help me organize the information. I know that rate times time equals distance. So in my table, I'm going to make a column for rate, time, and distance. Those are the important variables here. Now there's two different situations. We're given information about when she was driving during rush hour traffic and then when she was driving not in rush hour. The problem just gives us directly the time, so I'm going to fill that in. Her time in rush hour was 2.5 hours. And then later, not in rush hour, she drove for another 4.5 hours. So I'm given the time, so I'll just put that into the table. Now, they didn't give us the speeds, but they did tell us when traffic eased up, she was able to increase her speed by 40 miles per hour. So that means her rush hour speed, if we call that x, then later her speed would be x plus 40. We increase it by 40. Now, the only other information we're given in the problem is a distance traveled. And so what we can do in our table is if we take our rate column times the times, that'll give us expressions for distance. So if you're traveling x miles per hour for 2.5 hours, we can say that the distance traveled is 2.5 times x. I'm going to convert that into a decimal. I think that might make the equation a little bit easier. 2.5 is 2.5. So distance traveled during rush hour is 2.5 times x. I can use the same reasoning, and again, I'm going to convert 4.5 to 4.5. So I can take my time times my rate, x plus 40, to get distance traveled. So later, when she increased her speed, the distance traveled is 4.5 times x plus 40, rate times time. Now we still have to get an equation, and there's one piece of information we haven't used yet. We know that the entire trip, the total distance traveled was 362 miles. So that means if I take both distances, 2.5x and 4.5 times x plus 40, and I add those distances together, they have to equal 362. That's my total distance. And there's my equation. So let me rewrite this where I have a little bit more room. So there's my equation, 2.5x plus 4.5 times x plus 40 equals 362. I'm going to distribute the 4.5, and so now my equation is 2.5x plus 4.5x plus, and I did 4.5 times 40, that's 180, equals 362. Combine like terms, 2.5 plus 4.5 is 7, so 7x plus 180 is 362. Isolate the variable, so minus 180 from both sides. 7x equals 182. Divide both sides by 7. 182 divided by 7. 7 goes into 18 2 times. 2 times 7 is 14. Remainder of 4. Bring down the 2. 7 goes into 42 exactly 6 times. So x equals 26. All right, is this what they were asking for? They asked, how fast did Nancy drive in rush hour traffic? And if you go back to that original table, the x did stand for the speed in rush hour traffic. And so my answer is 26 miles per hour. If they asked how fast did she travel in the second half of the trip, later in the trip, not in rush hour, we could take x plus 40, and that's 66 miles per hour. But they only asked for the rush hour speed, so answer is 26 miles per hour. Here's another type of problem. This one involves money. A bank teller is counting $20 and $50 bills. If there are 6 times as many 20s as 50s, and the total amount of money is $3,910, find the number of each type of bill. So there's 2 unknowns in this problem: the number of 20s and the number of 50s. The information that I'm given is there are 6 times as many 20s as 50s. So if I call my number of 50s x, the number of 20s is 6 times x. Number of 20s is 6 times the number of 50s. The other information I'm given is the total value of the money. So what is the value of my 20s and my 50s? Well, each $20 bill is worth $20. So if I have 6x 20s, I can take 20 times 6x, which is 120x. So the total value of my 20s is 120x. Similar reasoning for the 50s. The 50s are worth $50 each. I have x of them. 50 times x is 50x. The total value of the money is $39.10. So that means 120x plus 50x is $39.10. Combine like terms, I get 170x equals $39.10. Divide both sides by 170, and I got x equals 23. So looking over here to the left, x was my 50s. So we have 23 50s. And then to get the 20s, I take 6 times x. 6 times 23 is 138. So we've got 138 20s, 23 50s. All right, let's do one more example. A student earned $6,200 during the summer. They invested part at 9% and the rest at 6%. If they receive $441 in interest after 1 year, how much was invested at each rate? So I think I'm going to set up a table for this one to organize the information. And I'm going to use the fact that the interest you earn is going to equal your investment, or principal, times your interest rate. So the amount of interest earned equals the money you put in times your interest rate. And we've got 2 different accounts here. We've got this 9% and 6% account. I know the interest rates. That's given to me. The 9% account, I'll write 9% as 0.09. 6% account, we'll write that 6% as 0.06. We don't know the amount of either investment. So I can call the first investment X, and then the second investment is whatever's left over from that total. if we put X dollars in the first account, the amount we have left would be $6,200 minus X, because we know that the total amount of money is $6,200. For example, if X was $200, if I put $200 in my first bank account, I would have $6,000 left for the second account, or $6,200 minus 200. Okay, then the column labeled interest earned is going to be your interest rate times your investment. So in the first account, interest earned is 0.09 times X. In the second account, it would be 0.06 times that quantity 6,200 minus X. So 0.06 times 6,200 minus X. Now to get our equation, there's a piece of information we haven't used. We know the total interest earned is $441. So if I take the interest in the first account plus the interest in the second account, that has to equal 441. In other words, my equation is going to be 0.09x plus 0.06 times 6,200 minus x equals 441. I'm going to distribute the 0.06, so now I've got 0.09x plus, so I took 0.06 times 6,200 is 372, and then 0.06 times negative x is negative 0.06x, and that has to equal 441. Combine like terms, 0.09x minus 0.06x is 0.03x, plus 372 equals 441, minus the 372 from both sides, we're left with 0.03x equals 69, divide both sides by 0.03, and I got x equals 2,300. Let's see, what are they asking us to find? How much was invested at each rate? So this 2,300, this x, is the amount of money invested at 9%. So $2,300 at 9%. And then the amount of money at 6% would be 6,200 minus x. So I took 6,200 minus 2,300, and I got 3,900. So $3,900 was placed into the 6% account, 2,300 into the 9% account. All right, that was my last example. I know these problems are involved, and I went through pretty quickly in this video. So please reach out if anything is unclear.